Hi everyone, my name's Lauren, and we're gonna go through a really fun STEM demo. It's called Chemical Gardens, and it's really fun because we're gonna get to see metal salts grow in sodium silicate solution, and it's something that I love doing at different STEM events that I am involved in. And it involves the periodic table, which is behind me. This is the Earth Scientist periodic table of the elements. It's my favorite periodic table, hands down. I love it. If you like the periodic table, I highly recommend the Earth Scientist one. It's super cool. But anyway, let's get into the experiment. So I'm gonna stop sharing my video and pull up my screen so we can go through chemical garden experiment and real world application. Let's see. Alrighty. So we're gonna be looking at chemical gardens. So I have this video and it's just going to go through chemical garden experiment and fast forward. So I poured out the sodium silicate solution and now I'm adding in metal salt. And for this demo, it was iron 3 chloride. So Fe for iron and then the Cl for chloride. And we're going to see what happens. And if you guys can see in the video, the iron chloride is growing. So we have some growth occurring over here, behind here, over there. This is a sped up version, so it does not grow this fast when you're doing the experiment and watching it in real time. But see, we had this growth here, we have this one, and then we had this bit, and it's falling over. That's the fun part about it, is how they grow and sometimes how they'll kind of like tip over as well. And now it's growing up the side here. There it goes. And that was a bit later on. So see, now we're at the 35 milliliter line here. And so it's growing and it's growing and it's almost turning into like this caterpillar worm shape, which is really cool. I love how it forms shapes like that. And there it goes. And so that was the end of the video. And so let's think about what happened. We're going to go through about what happened with this. So let's see. So these are just two pictures of the final product taken at different angles. So you see here we have this larger one that we watched growing towards the end of it, and this one kind of looks like a worm or caterpillar-like structure. It's really cool. I love it when they form things like this. It looks so awesome. And then we have this one here, like the smaller version of it, which is really cool. And they kind of almost form a heart shape if you look at them together in a weird way. They're kind of like a heart. It's kind of cute. But yeah, it looks super cool. I love formations like these. It's so awesome. So the main question is what happened? So how did that reaction occur and what was actually going on? So what we did was we took sodium silicate formula here, and also known as water glass or liquid glass. And so sodium silicate can be three things. So um, yes, it's known as water glass and liquid glass, but we have sodium metasilicate, we have sodium orthosilicate, and sodium pyrosilicate, and they're polymeric. And so when we say polymeric, it's like in that window box that was below the polymeric wording. It's just they're thin chains of polymers. So polymers are just kind of like these thin chains, and at the nanometer scale, so they're 10 to the minus ninth in scale. So they're super small. We can't see them with our eyes. We'd have to use a microscope and really zoom in and look at them. And so that's kind of what's present in our sodium silicate solution. And so what happens is we can add in metal salts. And so on the side there, I've just written up the chemical formulas of different metal salts that can be added. And these would all be recommended to do like in a lab setting just because of irritation to your skin. or just like if you get it on you, it's much better to do it in the lab with your safety gear on and stuff. But the last metal salt that I wrote down was the iron chloride, the iron 3 chloride, because that's the one that we were using for the video, is doing the iron 3 chloride. And the other fun thing that I want to point out about the different metal salts is that with each metal salt, they each have their own unique color that they'll grow in there. So like the calcium chloride would grow white, the copper sulfate would grow blue, and then the iron chloride one is going to grow kind of like that orangey brownishy color that we saw. So depending on the metal salt, they each have a coloration that they'll grow. So if you want to have like multicolor chemical garden, you just have to grow with different metal salts, and you can grow them in the same container. So I could have grown like 3 or all of them in the same tube, and it would have gotten a variety of colors, which is really cool that that can happen. But we add metal salts to sodium silicate. So then what happens? So we're adding in the iron chloride. So the first step is the iron chloride gets added and it starts to dissolve. But then we start having a double displacement reaction. And by double displacement reaction, all I mean is the bonds between AB and CD are going to be exchanged. So instead of AB plus CD going to be AB plus CD, we're going to have AB plus CD are going to form AC plus BD. So we're going to be exchanging our bonds basically between the two. And so that happens. And then we have 2B, which is osmotic effects, which are going to increase the pressure. And when we have that happen, in those polymers, there are holes made. And in those holes, we can start forming a solid. And that solid is what we see growing. And so by doing that, and with the exchange of the bonds with the osmotic pressure, we get these formations grow that we watched in the first video, which is really cool. And a fun fact about the osmotic effects with it is depending on where there's the most pressure, it's going to influence the way the things grow. So if we had the highest amount of pressure at the top of the liquid, we would have our formation start growing downwards. Whereas in that video, pressure was highest at the bottom, so they were growing upwards. If we could have flopped that, they would have been growing downwards, which is really cool to think about, like having things go down, really awesome. And so that was kind of how that happened, and that was kind of the reaction of how it happened. So can this be applied to the real world? And the answer is yes. There are multiple real world applications that we could look at, but the one that personally that I think is the coolest one to compare it to, and not just because I do biogeochemistry, so obviously I'm going to favor the geology, but it's hydrothermal vents. So hydrothermal vent structures that we see actually grow in the same way that we can grow our chemical gardens. And so the chemical garden experiment is a way that we can study hydrothermal vent formation and look at the different conditions and kind of see how they grow, which is really cool. So in a way, when we do this STEM demo, we like to tell the students who are there, who are watching it happen, that in a way, we're kind of growing our own hydrothermal vent. We don't have the stuff coming out of it, but we are growing similar structures that you might find at a hydrothermal vent, at least growing them in the same way. So that's the cool real world application, in my opinion. There are others out there too that are probably just as cool. But that was chemical gardens in a nutshell, basically. So I hope you all had fun, and I hope you all enjoy learning about chemical gardens and how cool they are to do. And I'll see you all next time when we go over another cool STEM demo, because STEM is cool, earth science is cool, chemistry is cool, biology is cool. All the sciences are cool. So see you all next time. Bye.